Test, test, test. All right, part 2 to see if I don't know if this will tack it on to the end or not, but we'll see. Screwed up and put my audio into headset up and forgot to switch it back when I came off mute. All right. Test, test, test. All right, the audio's up. Screen share's up. All right, recording is started. Yep, recording. All right, fine. All right, so let's try this again. All right, the databases have a variety of sources. You need to have different types of sources like .crm files, .erp files, or flat files, text files, JSONs, etc. You need to have all that data broken down such that when you read it, you break it into its 4 components, the ACID test, making it as atomic as possible so that you can have small components there in order to do fast transactions, consistency to ensure that it's stable across and that it's everything, all the different sources can be merged into a single set together. Isolation so that it's not visible to other transactions. Durable so that it doesn't have failures, and once you get all those types of sources put into it, and you export it to a data warehouse to store that data so you can mine it for information, create business intelligence, machine learning maybe on it, do reports for people to understand what to do with it. There is a process for the data mining. The data mining is all about extracting information and producing knowledge based on information stored within the warehouse. So the idea is you migrate the raw data from your source, you process it, you transform it, you create reports based on it. You look for patterns, you look for consistency issues, you try to find out how to make best use of, let's say you have 1,000 inputs from a single sensor, and you need to normalize that data so you have consistency across the data, and you find out where your anomalous issues are, fix those, but overall you can then generate data so that it can be actionable. Knowledge is based on actionable data. Knowledge can be given a business to either to improve its processing, to do its transactions, to make business decisions, or decision makers use it to go forward, right? Your durability is all about ensuring synchronization across multiple facilities or from your front end, back end to ensure consistency of the data being processed. The example that would be like, if you have multiple geographic locations, then you had your front end, such as Amazon, where they do user transactions, or eBay's using user transactions. The front end is about providing the website to the users, about allowing them to do searches in the system, and in order to look up quantity, look up availability, find out sellers, find out prices. The back end is about executing the transactions, ensuring that they have it at their locations, ensuring the database, the data warehouses, or the physical warehouse can process that transaction, can send that product to shipment, make sure it has the quantity, it's synced up on a regular basis. Additionally, you may do synchronization of databases across multiple geographic locations, right? So if good redundancy would allow you to synchronize live data at all times to all locations, or you may have major hubs where you're, such as here, where Boston and London are synchronizing their data. But if a break in the communications occurs, it doesn't prevent your systems from transacting, but you need to work on trying to get the reestablish and link at a later date quickly, so that you can get any synchronizations across there to be processed into, so that one site knows about the other and they can all go back to being consistent data across things. So in order to make the data as small as possible for the ACID test, it could also be that on the back end, your warehouses, specific warehouses, may have quantities and stuff, and they need to get low on certain things that need to stock up by reordering. So that may cause delays of shipments of a particular order based on it needs to come from another location as opposed to this local site and then processed out from the local site, right? So let's think about Amazon's scenario in that case. Durability also needs to be resilient in such that you want your data to be hack resistant. So you don't want to be like Verizon did several years ago, where they used to have their data of all their user accounts stored on an S3 Amazon backup, and over time that got hacked into, which exposed all of their user data, and since people rarely ever change their passwords, all that data then got extracted, and then many bad things occurred with identity theft in that context, right? Because people then use that information to spoof records that they had for other identity theft transactions on the users of Verizon. But that was because they ended up inadvertently storing all of the old data in long-term archive on an S3 system, such that it was available for hacking and resource extraction, right? So people did data mining on that old data and figured out things that they could use for actionable information against Verizon, against its customers. Inside the tool, you need to make sure you work with your architects to determine what tools you need as a database administrator, database maintainer, or architect, to ensure that you get the consistency of the data, processing the data, make sure you can make standardized data warehouses that are using a common set of tools, and make sure you do quality storage and spot checking for consistency and verification. You want to make sure your systems are resilient enough to be able to handle natural disasters and viruses or ransomware attacks. At the same time, you also need to make sure you have multiple sites. You have a hot online backup. You have a cold backup and a cold offsite backup. And the reason being is that over time, you need data as it comes older to be archived to longer, colder storage that you don't have to touch as often or as needed, but only acquire when the event of something major happens, especially in cases of smoking holes, right? If smoking hole scenarios, basically you have to assume that a facility is wiped off a map, and what would happen in order to keep a business functioning from a business continuity standpoint and a disaster recovery standpoint. You need to know how to keep a system up and functioning in the event that you have a smoking hole scenario, and your database needs to be data warehouses need to be resilient enough to allow your system to not become lost or go out of business because of the loss of like 1 or 2 days of a smoking hole scenario, but able to last long enough such that they can recover and go back to being fully functional within the time needed, the critical path time. Seasoned professionals search out tools. In this case, you need to make sure you have enough tools and the right set of tools to do the complexity of your database management and your database warehouse addition activities, and you have the correct number of programming languages needed to reach that data as needed, right? The right set of tools, the right types of tools, and the ability to do the right type of work. And you don't need an overabundance of tools, but you need to have the right set of tools. And sometimes please work with your architect for your infrastructure to make sure that they can defend and acquire what you need in order to do the job correctly. Make sure you do regular audits to convince yourself that you have the ability to get the correctly functioning, and that you have that information available, and that you are able to, in such a ways, ensure that you have the same processes are able to be downloaded over and over and over. Decision makers need to have a better insight into the businesses at which they are available, so you need to have the tools that can extract data, turn it into something actionable. Stuff that can be actionable from a business or a management perspective allows the right people to do the right type of jobs that they need to. Make sure as part of your processing, you have a correct set of tools that do good maintenance, good cleanup. Make sure your records are as clean as possible, and you don't have any garbage data sitting around inside of your warehouse that people can accidentally stumble into or take action upon that they should not be taking action upon. And then make sure it's all as consistent and meaningful as possible. Your loading process needs to ensure that you correct the right type of data, not spend an inordinate amount of time doing so, but you are auditing for spot checking for consistency to make sure that your systems can sustain cyber attacks, viruses, natural disasters, and other compromises. Question answer time. Warehouses do not usually feed. That is false, because warehouses are, or data marts are actually specialized versions of a data warehouse where they are subject matter expert specific for a topic. So specialized such that in the case of like Amazon, they may have a data mart that is solely about the prices of goods and ensure that, or it could be solely about the customer data, so that they have as clean of a data warehouse of a data mart as possible, and then they can pull from multiple data marts to generate correct records for accessing. OLTPs usually feed warehouse. That is correct. And this is the typical six-step process by which an OTLP does what it needs to in order to produce the artifacts needed for decision makers to actually process and execute. Right? Database is usually just transact processes. OLTPs are about the whole transactional process in order to make sure that the reports going in and the data going in and the reports coming out are able to provide business intelligence. Legacy systems are where data may come from warehouse. That is not necessarily the case. Legacy systems are basically systems that are no longer being actively maintained or managed and may still be actively used. Generally, they're bad for a system because over time, windows of vulnerabilities tend to increase on static systems over time as new exploits and hacks and information become known about various things, various components, operating systems, etc. And legacy systems are therefore bad for an organization to become known with known vulnerabilities and easily exploited by cybersecurity. So they could have produced information. They may still be producing information, but legacy systems need to be decommissioned as soon as reasonably possible and replaced with active systems that are regularly maintained. And all the processing functions and the database functions need to be migrated accordingly. Data modeling is not important. That is false. Data modeling is all about making sure the right type of data tables are built, the right types of information is stored, and the data can be quickly and easily accessible, either through metadata or for fast search and processing by a data warehouse. That could be make sure you have the right keys, the primary keys, foreign keys, your fact tables, etc., multiple sources, all co-aligned such that you can do quick ETL processing. Normalization is necessary. That is true. It's in order to reduce issues with data at a later date. Data marts are more specialized versions. That's true. They are subject matter expert specific type of data collections and are usually more condensed and more focused on specific types of purposes or functions. They're easier to implement than let's say with large scale data warehouses. A good deal of business function for large functions is not derived. That is also true because it would not be possible. Business intelligence is not possible without data warehouses. The ability to do actions based on collections of data, the actionable data piece is what's important. Businesses make decisions based on actionable data. So, all right, hopefully the second part actually recorded correctly and you now have this. I don't know if it's going to come up with a second file or if it's a continuation of the same file, but hopefully it all works in the end. With that in mind, thanks for your time and good luck in your future classes.